Okay, so today we're tackling question 2 part B. In this question we are given a rational function f of x equal 3x minus 4 on x plus 4 and a diagram that shows the graph of f. We are asked to do two things. First, we want to insert the asymptotes for the function f, and second, we want to sketch the graph of the inverse of f and show its asymptotes. Okay, so let's start with part 1 and find the asymptotes to show them on the diagram. The vertical asymptote occurs when the denominator of f of x is 0, that is when x plus 4 is equal to 0, so that we get x equal negative 4. Therefore, the line x equal negative 4 is the vertical asymptote. To find the horizontal asymptote, we consider the value that f of x approaches as x approaches infinity. That is, we consider the value that 3x minus 4 on x plus 4 approaches as x approaches infinity. We divide throughout by x to get 3 minus 4 on x all over 1 plus 4 on x. As x tends to infinity, 4 on x tends to 0, so we get 3 divided by 1, which is equal to 3. Therefore, the line y equal 3 is the horizontal asymptote. Here's the graph with the asymptotes inserted. The blue line at x equal negative 4 represents the vertical asymptote, and the green line at y equal 3 represents the horizontal asymptote. Note that if you didn't know how to do the calculation to find the asymptotes, then you could have guessed where to place them based on the graph that was given. However, by doing the calculation, we can be certain of our answer. Let's move on to sketching the graph of the inverse function. To do that, we first need to find the inverse function. So put y equal to 3x minus 4 on x plus 4 and solve for x. Multiply both sides by x plus 4 to get y times x plus 4 equal 3x minus 4. Expand the term on the left hand side to get yx plus 4y. Let's group all the terms involving x on the left hand side by subtracting 3x from both sides, and let's carry the 4y onto the right hand side by subtracting 4y from both sides. So we end up with y times x minus 3x is equal to negative 4y minus 4. Let's multiply both sides by negative 1 just to get the a nice term in the end. So doing that, we get 3x minus yx is equal to 4y plus 4. The term on the left hand side has a common factor of x, so let's factorize to get x times 3 minus y equal 4y plus 4. Assuming y is not equal to 3, we can divide both sides by 3 minus y to get x equal 4y plus 4, all divided by 3 minus y. Therefore, the inverse function is equal to 4x plus 4, all divided by 3 minus x. Now that we know the function we need to sketch, let's find some of its key features. For instance, its y-intercept, its x-intercept, a few other points, and its asymptotes. Its y-intercept occurs when x is equal to 0, so substituting for x equals 0 in the inverse function, we get that y is equal to 4 times 0 plus 4, all divided by 3 minus 0, which is equal to 4/3. Therefore, the curve cuts the y-axis at 4 on 3. Its x-intercept occurs when y is equal to 0. So putting 4x plus 4 divided by 3 minus x equals 0, we get that 4x plus 4 is equal to 0, which implies x is equal to negative 1. Therefore, the curve cuts the x-axis at negative 1. To get a reasonable sketch, you should find a few other points. I decided to use these coordinates since they worked out to be nice, neat integers, making them easy to find and plot on the graph. Finally, we need to find the asymptotes. It has a vertical asymptote when its denominator is 0. That is when 3 minus x is equal to 0, so that x is equal to 3. Therefore, the line x equal 3 is the vertical asymptote. To get its horizontal asymptote, we find the value that the inverse function approaches as x approaches infinity. That is, we find the value that 4x plus 4 on 3 minus x approaches as x approaches infinity. Dividing throughout by x, we get 4 plus 4 on x, all divided by 3 on x minus 1. As x approaches infinity, 4 on x approaches 0, and as x approaches infinity, 3 on x approaches 0. So we end up with 4 divided by -1, which is equal to -4. Therefore, the line y equal -4 is the horizontal asymptote. Question: what do you notice about the asymptotes of the inverse function with respect to the original function? Think about that for a moment before continuing. Anyway, with all the data that we collected, here's a sketch of the inverse function along with its asymptotes. The inverse function is the purple curve. The vertical asymptote is the brown line at x equal 3, and the horizontal asymptote is the red line at y equal -4. Note that you can try to sketch the inverse of f by reflecting its graph in the line y equal x, but that can be an error-prone process. So my advice is to do the calculations as I did above. However, you can use, and you should use, the reflection criteria as a visual check that you did the right thing. Anyway, that's it for now. Hey guys, Dwayne here. If you're a Caribbean student struggling with Cape Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching, and see you next time.